some methods that prints exception message, right? So there are many exception messages that needs to be displayed to the end user. Whenever an exception is created, so the end user, if there is any exception generated in a particular program, we need to understand what kind of exception is there, right? For that, the exception handling concept has provided three methods under the throwable class. We have a class called throwable. So under throwable class, there are three methods that is going to display the exception message to the end user. So let me categorize those three methods. So this is 1, 2, 3. So the first method is printStackTrace is one of the methods. You can say it as e.printStackTrace. This is one of the methods, and the second method is we have a method called e.toString method. And lastly, we have a method called e.getMessage. So these three methods are used for different purpose. We will understand each and every purpose, right? So what I'm trying to say is there are methods that is going to print exception message for the end user. So the end user need to understand whenever an exception is generated, what kind of exception, the exception definition needs to be displayed in the console, so that the end user will get to know what kind of exception is entered. We commonly know that in order to handle any exception in Java, typically we are going to use what? We are going to use a try block, and we are going to use the catch block. This is the typical way to handle any exception in Java. A try block followed by a catch block. And we already know that this try block is going to, we have to, the risky code needs to be mentioned in the try block, risky code. Usually the catch block is going to have an alternate code. If an exception is occurred, an alternate code has to get executed. So we will place the alternate code usually in the catch block. Isn't it? This is a typical example of handling an exception in Java, try block and the catch block. So it's okay. We are going to include an alternate code in the catch block. At the same time, what if the end user wants to know what kind of exception has occurred actually? Right? So when you run this program, so as soon as the JVM is encountering an exception, it will look for the specific catch block and it is going to execute the alternate code. You know this already, right? So this alternate code execution is something normal, and this is how an exception can be handled. But apart from that, what if the end user, what if the developer wants to get to know what exactly the exception, what kind of exception has occurred exactly? That information, if you want to display, we can display that information by using these methods. You can use these methods to display that information, right? So let us understand the first method, which says, before even proceeding with this, let me take you to the STS. So this is the STS. In the STS, I am going to use a risky code, which is 10 by 0. So this 10 by 0 is a risky code which is going to generate what? Arithmetic exception. We know all this, right? So as soon as the exception is generated, the control will look for the main thread will look for the catch block. So we have also declared the catch block. So inside the catch block, we will include a alternate code which has to get executed, because this is an exception. So the catch block will contain an alternate code. So in this case, I am going to mention this as, for the better understanding, I am going to keep this as alternate code. So when exception occurs, alternate code will be executed. Let me run this. So we are getting the output as alternate code because this code is getting executed because of this exception. What if there is no exception? In this case, there will be no exception, so that there will be no chance for this catch blocks to get executed. This time the catch block will be skipped because in the try block there is no exception, right? So the output is going to be water, right? Right. So what if I want to display this exception? So this is an arithmetic exception. I want to display this arithmetic exception, right? So if I run this, I'm possibly I am able to see only the alternate code. So this is something that is getting executed. Since I have written this as alternate code, right? It is not like it is executing an alternate code. Simply like so the exception has occurred here. To execute the code that is available in the catch block. This is an alternate. But I want to display the exception, name of the exception. This is an arithmetic exception. I want to display that information. In that case, I will be using one of these three methods. In any one of these methods, I can use to display this information. Sir, how can you display? Then what is the difference between these three methods? How this could be differentiated between each other? If you ask me kind of question, I have a direct answer. Whenever I am using e.printStackTrace, let me use this. printStackTrace. If I use this, it is going to display three informations to me. See? It is going to display the name of the exception. Firstly, right? Secondly, it is going to display the description, why the exception has occurred. Third, it is going to display the what? Stack trace. Stack trace is nothing but at what line the exception has occurred. Right? If I take this example, e dot print stack trace, I can just give a if I want to give a briefing about this method, I can say it is going to print the exception information, or I can say it is going to print the detailed exception information. Like first one, what? Name of the exception. Secondly, description of the exception, description. Thirdly, stack trace. Stack trace is nothing but we can say that the line number of the exception, the exact line number the exception is occurred, the exact method and the line number where the exception is occurred. Stack trace information. So these three things I am able to see these three things when I use e.printStackTrace method. It is going to give me all the exception information. Okay? So it is just giving me the exception information in without any interruption. The remaining code is getting executed normally. There are no issues with execution. The code is getting executed normally, and there is no abnormal termination. Everything is getting the normal execution. Along with that, I am also able to see the exact exception that I am going to get, such as exception name, exception information, on which method the exception occurred, main method, which line, exactly its date number. Even I am getting the line number information. See, the exception has occurred on the exactly at line number. Right? So let me push this line to, let me add one more space. So line number now. Let me add one more space. I am going to get the exact line number information because of this. So if you ask me whether how much it would be helpful. It is very much helpful because I can trace the exception. After running the code, after performing the execution, actually I can trace the exact line number, exact exception that has occurred. It will be very easy for the developers, for the end users. So this is how, this is the usefulness for the e.printStackTrace method, right? And if you are asking me, if you want to ask me about the prototype of this method, the prototype is very simple. It is not going to return anything. The prototype is the return type is void. Void print stack trace. So this is how the method looks like inside the throwable class. Let me show that here. So e.printTrace is return type is void and it is available in what? Throwable class. It is not going to return anything. That's why we can directly, why I am using e here, because here I have declared a variable, user defined variable as e. I'm declaring here as w, right? It should be w, right? I hope there is no confusion, right? I'm using this exception variable, using this variable to get access to the printStackTrace method, right? So if you look at the exception hierarchy, this is how it looks like. We have a throwable class. After throwable, we have an exception class. For exception, we have an what? We have a runtime exception. For runtime exception, we have arithmetic exception. So this is how the inheritance concept. This is what we have understood from the inheritance concept, Java inheritance. Child class, parent class, grandparent class, super grandparent class. Right? If you say this is throwable, this is exception class. Exception class is a subclass of child to throwable class. We have runtime exception. And following which we have what? We have arithmetic exception. So we are trying to get access to a method that is available in the throwable class. Inside the throwable class, we have a method like printStackTrace. So this is one of the methods that is available in the throwable class. So see, if you look at this program, here in the catch flow section, I have used the exception class. So I have created an object for exception, which is C. With this reference, I am getting access to printStackTrace. In the exception, I have created a variable called E. With this variable, I am trying to get access to printStackTrace. You can also create a variable for a runtime exception. You can also create a variable arithmetic exception. With these variables, you can get access to the grandparent classes. Let me show that also. Here I have written exception. Instead of exception, I can also use what? Child class, which is runtime exception. So let me use the same variable name. With this variable, I am able to get access to the printStackTrace method, which is available in throwable class. Because all the child classes has common rights, equal rights to get access to the properties and behaviors of the parent class. Same thing is happening. Right? Hope this is making sense. Okay, if you have understood this, and it is very easy to understand the remaining two methods. The second method is what? e.toString method. So printStackTrace method is giving us the three information: name of the exception, description of the exception, and the stack trace information, right? If I try to use sum.out.println and e.toString, this method is going to give me only two information. One is name of the exception and description of the exception. Let me take this. Second method is what? E dot toString. So it is giving me two information. Earlier, like E dot print stack trace has given me three information. Now it is giving me two information. Information that we get is simple. So I can write the same thing. It is going to give me two information. I mean, it is going to give me some information regarding the exception, such as first one is what? Name of the exception. Second one is what? Description of the exception. As simple as that. Right? And if you ask me, why did I write this in the system.out.println? Because this is a toString method, and toString method is overridden in the throwable class. Right? ToString method is overridden in the throwable class, and it is returning string. The previous case, it is not returning anything. That's why we were able to just write it like e dot print stack trace, because the return type is void. If the return type is void, it is obvious that we should not include this print stack trace in the system.out.println statement, because the return type is void. It is not returning anything, we cannot catch anything. But in this case, this return type is string. The toString method return type is string. Let me show you that. Instead of writing like this, you can also write like string. We call it as exception catch equal to e dot toString. You see, toString method is return type is string, which is in the throwable class. Right? I can directly, you make use of this variable which is exception class. Since it is returning a string value, I am able to write that in the system.out.println statement. So this is another way that I can represent this method. Right? I'm able to get what? Name of the exception, description of the exception. Right? Or else instead of using e dot string, I can directly use e as well. No issue. I can directly use e. Even I can use directly like this, or else I can use e dot toString. Internally, it is going to call toString method, but understanding is required. Right? So by in a nutshell, I can simply say that this e dot toString method is going to display two set of information, which is name of the exception and the description of the exception. Previously, we were able to see three set of informations: name, description, and stack trace name. Now it has been reduced to two because of this e dot toString method. Okay. Hope you're able to understand. You can able to differentiate it yourself. It's a self-explanatory. Don't think much explanation is required. And let us talk about the third exception, which is e dot getMessage. Third method is what? E dot getMessage. This is also self-explanatory. Previously, we were able to see two pieces of information, which is name of the exception and description. So if you are going to use this e dot getMessage, let me write it as e dot getMessage. Sorry, this is not there. You will be able to see only one information, which is the description of the exception. Right? So simply I can say that please use it to get only the description of the message. This is the example. So these things are self-explanatory. In a nutshell, I can simply say that there are three methods in the throwable class. So throwable class is going to, usually it has three methods. These are the three methods: e.printStackTrace. Its return type is void. So these two exceptions as a return type as string, right? So the first exception, which is printStackTrace, whenever you are using this method, it is going to give this three information. All the information regarding the exception, the name of the exception, description, and the stack in stack trace information. The line number where the exception occurred and the method where the exception occurred. All this information will be given in the console or given to the end user. Secondly, we have a two-string method. It is going to display only two information. One is name of the exception, and second is description. The third method is going to display only one information, which is nothing but the description of the exception. Right? So these are the methods, most commonly methods and important methods to display an exception message to the end user or the developer. So this is the program, this is example program. And again I am telling, like, the code that we are declaring here is the handling code. And you can ask me, what if what if the handling code is not given? For example, I am saying I am just using a catch block. Inside the catch block there is no handling code. So I am like describing a code, or just adding another code outside the catch block. Outside class. So exception is occurring on the 10th line. As soon as the exception is occurred, it will search for the catch block. Right? In the catch block, the alternate code will be executed. But here in this case, I have not given any alternate code. What happens here? Still the program is getting executed. If you are able to see, still the program is getting executed, because even though we are not specifying the alternate code in the catch block, the program is getting executed successfully, because we are able to print the last statement in the main method, which is outside. So it is not mandatory to define an handling code, but it is always mandatory to declare the catch block. Right? It's not mandatory to define handling code, but it is always mandatory to declare the catch block. Because try block, whenever the try block is declared or specified, we have to ensure that the try block follows the catch block. You cannot independently, you cannot do this, not possible, and you cannot do this as well, not possible. The conclusion is try and catch block should go together. They should always travel along together. And the handling code is not required. At the same time, you want to display what the exact exception, you can use these three methods. One is what? printStackTrace. It will print all the information regarding the exception. Right? Secondly, what? We have a getMessage, which is going to display only one information. Thirdly, we have e.toString. It is going to give two information. Very simple, isn't it? So these are the methods that can be used in the catch block to make sure that or to get the exact exception information to the console, to get printed in the console.